Hey, welcome to this lecture. I'm going to be talking to you about the golden spiral, the golden ratio, and phi in this lecture, and why it's important to know as an artist and how it can help you in your compositions and your understanding of nature. So here you can see on my screen that I have this sort of strange looking diagram made of squares and numbers and giant spiral here. So this is known as the golden spiral, and this is what's found in nature. And if you can imagine a little like snail shell, you know, like a little garden snail, like this is the mathematical structure of how his shell grows, and it's found all throughout nature in all kinds of different things. Basically any kind of organic structure you can think of will somehow have this spiral implemented in it. You can find it in all kind of proportions. So let's get into a little bit of what it's about. So let's break it down. So it always starts with numbers. So this is what I want to drive home with this. This essentially comes down to a mathematical equation, and we'll get back to this picture once we go over these things quickly. So this symbol right here is called phi. It's the Greek letter phi, and it is the answer to this equation right here. Also, it has something to do with this diagram too. So it's a couple things mixed together, but I'll break it down for you simply and in a way that you can easily digest it. You don't have to really know all these equations as an artist. You really need to just know how that spiral looks and how it constructs the organic structures in real life, and how math and art are interconnected. And they don't really teach this stuff in school. That's why I wanted to include it in this course, so you can kind of bridge that gap in your understanding of how your drawings and how art in general is connected to math. And they kind of split these two things up in school, and in my understanding, it's kind of a detriment. It would have been really helpful if they would have taught me how these two things go together and how they're not so different as you might think. Everything's not so compartmentalized. Okay, so this equation right here, a over b equals a plus b over a equals b over c, equals 1.618 equals phi. Might seem like a lot of numbers and letters and symbols, but let me explain what that means. Also, phi is the symbol for the golden ratio. Okay, so we have two line segments here. Line segment 1, line segment 2, both are the exact same length. B plus C is A. Makes sense? Same length. So what the golden ratio is if we take this line of A and divide it at one particular point, we get a special system that works perfectly. So if A equals 1.618 inches, B equals 1, and then we can figure out this equation using that. So if A equals 1.618 divided by 1, everything starts to work out here, and we get 1.618 at the end. Phi equals 1.618. So essentially what this is about is at this point, at this division point, and it's all about the division point of a singular line. If this division point is placed correctly, A divided by B also equals B divided by C. and there's only one point on that whole entire line that can provide that perfect ratio, and this is known as the golden ratio. So if we go back to our golden spiral here, we can start to put that together. You can see how this square here is divided just like that line here, how this is divided. You can see how that's divided, and we get this new projection from here that is equal to those put together, which will allow us to create a brand new square, which is 13 plus 8 is 21. So if we can imagine that each square is perfect in this diagram, meaning each side is the same length, so this side's 21, this side's 21, this side's 21, this side's 21, of whatever type of measurement you want. It might be inches. Each side is 21 inches. The new projection that comes off is another perfect square, and this is 34 inches on each side. And this is calculated by adding 13 and 21 this time. That's how you get 34, and so on, and then you get a new progression. So this is like an infinite diagram that can keep going on forever. Like you could have a massive snail shell, and snail shells will usually go like 5 giant spirals after this, but it's a mathematical equation that exists in nature that like keeps like a perfect pattern going and like perfect symmetry, and things just look nice when they're held together in these patterns. And you'll start noticing it probably after this lecture. And I suggest you go look at a picture of like a snail shell and try and look for it in anything, and you'll be able to find these types of divisions. For example, if you look at your finger, you may see that the last 2 joints start to appear like a golden ratio compared to your first joint. So essentially, this is the magic number that you have to consider when looking at the golden ratio, and that's what makes all of this work. Now, you may have also heard of something known as the Fibonacci sequence. That is also connected to this golden ratio. It was discovered by a man in Italy named Leonardo Fibonacci, and it goes something like this. These are the first few numbers of it. So let's see if you can decipher how this is working and how it connects with the numbers I have placed on the golden spiral, and so on. So as you can see, these are the same numbers: 89, 55, 34, 21, 13, 8, 5. This one's 5. So what Fibonacci discovered was this sequence of numbers. So basically what you do is you add the number before, and then you get the next number. So 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, and so on. And you can see how that fits in with this as well. So I really, with this lecture, I want you to start to understand how math and art do go together, because art, we're trying to create illusions, especially if we're doing things realistically. We're trying to create illusions that match nature. So you gotta go down to the basics and say, how is nature constructed? And they'll give you a lot of answers. So this goes along with the compositional rules that I was telling you about, you can use this as a composition. Basically, how you're going to do it is you match up this point right here, that really congested point of the spiral, with your main focus. And over here you may have something bigger like that, and maybe some little things, you know, but you can use it to your advantage. And maybe you want to combo it with some other types of compositional rules at the same time, just to make it even stronger. But it is a very good tool in helping you create beauty on that page. And as an artist, our job is to basically sell beauty. So yeah, use the rules of nature. Okay, I hope you learned a lot in this lecture. I'll see you in the next one.